Hi everyone, in this video we're going to sketch these three trig graphs. So all three of these have a bunch of different transformations. So we're going to have to consider not only dilations, which are a little bit easy because that's just our amplitude and our period, but also horizontal translations, which can be a little bit tricky, vertical translations, which aren't as difficult, and we've also got one with a reflection, so that's good. Add that in, not to forget reflections. And we've got a domain of negative pi to pi for all of them. So what we might do is also go through how to do your endpoints. Because we've got a shift, your endpoint isn't necessarily going to be just sine pi, which is 0. You've got a shift, so it is going to be different. So we'll go through how to do that. All right, so going to be a long video because I'm going to do all three questions in the same video, but I strongly encourage you at any time to pause and perhaps have a go at doing it on your own. All right, and I'll try not to make any mistakes. All right, so for the first one, let's identify what is happening with this function. So we've got an amplitude of 2, a period of 2 pi on n. So in this case, our value of n is the number at the front of the bracket. So 2 pi on 2, which is pi. And the translations, we've gone to the left, pi on 3, and we've gone up 1. So let's first of all draw our y-axis scale. So there's our y-axis, and here's our x. It is x, so remember it can be theta and it can be t, or it can be anything, really. Usually not y. And probably not n because you use n to calculate the period, but it could be. All right, so it's whatever the independent scale is. Axis, sorry, couldn't find the right word. All right, so on your y-axis, let's do that in pink so it stands out a little bit more. So our amplitude is 2. So typically if it was an amplitude of 2, it would go from -2 to 2. But this has been shifted up 1, so your range or your graph is going to go from -1 to 3. So when we've had a vertical translation, you can see I've started this question and then I've started again. You can draw your dotted lines just to help guide you draw your graph. So this dotted line is basically our maximum. So the maximum for this one for this function is 3. And the minimum is -1. So that's your range, -1 to 3. All right, and then halfway is here. All right, so usually with a normal, so I shouldn't call it a normal, with just your basic sine x graph, your x-axis would be the halfway point. So it's just shifted up 1. So you can see that's just going to help us sketch our graph. And let's just complete the scale. I'll put 1 here. All right. Now for your x scale, all right, we've got a period of pi, but we've also been shifted across pi on 3. So to make it a bit easier to see that shift, it's probably, so we still split our our period in 4, but with our minor lines, it's probably a good idea to go up by pi on 3. If I go 1, 2, 3. So also because, sorry, I'm thinking while I'm doing this, because we've also splitting pi into 4, so basically that scale would be pi on 4. It's a little bit, so if we were just to split that into 4, we would have pi on 2, pi on 4. 3 pi on 4. Okay, because this scale is kind of different to this scale, the pi on 3, we've got to look for a common factor. So we're going to use pi on 12. So I'm going to make all of these pi on 12. So just to show you with the first one, that's pi on 12, 2 pi on 12, 3 pi on 12, 4 pi on 12, 5 pi on 12, 6, 7, 8, 9, 10, 11, 12. So 12 pi on 12, which is pi. All right, it's going to be a lot of work to fill all of them in, but I can still split that into lots of 4. Okay, so your halfway point is going to be 6 pi on 12. So 1, 2, 3, 4, 5, 6, which is here. And then halfway between that is 3. 1, 2, 3. And then we got 1, 2, 3. All right, I think when I explained this scale earlier, I kind of made a mistake with the pi on 3. This isn't pi on 3. This is, 3 pi on 12. That's what happens when you start a video very early in the morning. All right, 3 pi on 12, which is effectively pi on 4. All right, so 3 over 12 simplifies to 1/4, and then we've just got the pi there. So that's pi on 12. If you want to keep them in terms of twelfths, it's probably a little bit easier. So this is 6 pi on 12, which is the same as pi on 2. And then we've got 9 pi on 12, which is the same as 3 pi on 4. And then 12 pi on 12 is obviously pi. And I've just noticed another mistake. Gosh, sorry, it should be a 12. I need to focus a bit more. There we go. Okay, so we've split the pi, which I've written as 12 pi on 12, into 4. And we're going up by pi on 4 each time. But we've just written, instead of writing pi on 4 or writing the simplest fraction, I've just had them all with the same denominator of 12. So when we do our horizontal shift, it's a little bit easier to see. Okay, so I'll go over that again in a sec. So I'm just going to do this side as well, so it's a bit easier to see. So just write, do that pink, sorry. So this is negative pi on 4, which is the same as 3 pi on 12. Negative 6 pi, oops, sorry, I want to write this in their simplest fraction so you can see. Pi on 2, negative 3 pi on 4, and pi, negative pi. So the fractions on the left are the same as the fractions on the right, they're just negative, all right? And on the left side, I've written them in their simplest form. On the right side, I've kept them with a denominator of 12, just to make it easier when we do that horizontal shift. All right, now you can do this all in one go if you feel confident, but I do think it's a good idea to sketch it without the horizontal shift first. So in orange, I might just do it in a thicker one so it's a bit easier to see. In orange, we're going to do y equals 2 sine 2x plus 1. So I'm not going to do that horizontal shift just yet. All right, because a horizontal shift is easier once you draw your dots. And it'll make sense once I draw the dots. Okay, so your sine graph usually starts at 0 because we're shifted up 1. It's going to start at 1. All right, and remember we only focus on these quarter points, so these green points. So then we go up at 3 pi on 12, then back down at 6 pi on 12, and then down at 9 pi on 12, and then back up at 12 pi on 12. And we do the same with the other side. So then we go down at negative pi on 12, up negative pi on 2, up at negative 3 pi on 4, I forgot a pi, and then negative pi. Let's put that pi on here. Now you can do your shift just with your dots. All right, so with your dots, you can just do the shift without sketching it. But if you're sketching it, just do it faintly in pencil. So I would just go very faintly in grey lead. Obviously I'm doing it in orange, but just to show you. Or if you're using colour, use a different colour to the final function, just so you can differentiate between them. All right, so that's the graph of 2 sine 2x plus 1. Now we have to do the horizontal shift. All right, so down here I said we're going across pi on 3. That is the same as going across as 4 pi on 12. All right, so if I wrote pi on 3 as a fraction with a denominator of 12, it's 4 pi on 12. So every orange dot goes across by 4 pi on 12. So let's do it in dark blue. Okay, so we'll start at the right side, because then we're going to the left. It's a little bit easier to do. So you can just go 1, 2, 3, 4. That's 4 12ths. So that point has shifted to here. Because it's going to be a bit messy just drawing those little squiggles, it's probably not a good idea to do it for all of them because it's just going to be so messy. I would just do the one line and then move to the top, just so you don't miss any dots. All right, so then we're at this dot here, 1, 2, 3, 4. So shift it to there. Then this dot, 1, 2, 3, 4. Shift it to here. 1, 2, 3, 4. And then this last dot's going to clearly go past pi, but we'll draw it anyway. 1, 2, 3, 4. We'll just have to remember to do our endpoints. And I'm going to draw this point here, okay, which is if I kept going, it would be shifted to there. The reason I know it's there because the difference between the 2 points is 4 pi on 12 in one direction or 2 pi on 12 in the other direction. All right, so then let's do the top points. 1, 2, 3, 4. There it is. 1, 2, 3, 4. Just here. And down the bottom. 1, 2, 3, 4. 1, 2, 3, 4. And I need to draw a point here. So do 1, 2, 3. So 1, 2, 3. So we're up here. All right, so there, and then we just have to join the dots. Okay, so let's join the dots for the graph. We'll tidy up the endpoints in a sec. See how messy it's becoming. Very colourful though, very colourful. All right, so there's your graph of 2 sine 2x plus pi on 3 plus 1. We do have to stop at pi, so our endpoint is here. All right, so let's see if I can delete that without deleting the whole graph. Good. All right, so we've got to stop there, and then on the other side, we're stopping here. So you can see it's the same value, which is good because then we only have to work it out once. All right, so do make sure you stop there. To work out those endpoints, we just substitute in negative pi and pi into our equation. So y equals 2 sine to negative pi plus pi on 3 plus 1. So you can work that out. Just for now, do it on your calculators because we're going to solve equations after we've done the graphing plus 1. So we'll come back to the graphing after we've done solved equations. So let's just go on the calculator. I don't have it there. All right, so don't know what that was. Hopefully it works. All right, so when you're doing it, just go to where we got 2 sine 2 negative pi plus pi on 3. Close your brackets plus 1. You'll notice in the calculator they've opened the brackets there at the 2, so just make sure you put another bracket in there. And it should probably give you the first answer. All right, so root 3 plus 1. So if we're having it in exact form, there it is, root 3 plus 1, or you can press decimal if you want to change it to a decimal. There it is, 2.73, which we can kind of see is what it should be because it's just before 3. So I'm going to leave it in exact form because I think you should always have it in exact form unless specified otherwise. So this point here is negative pi, whoops, negative pi root 3 plus 1. And over here it's the same. So pi root 3 plus 1. But when we go through the solution of how to solve trig equations, then you should be able to do this. It's actually not that difficult if you want to have a go at doing it, but we'll be doing solving soon. All right, there it is in all its colourful glory. The next one we're going to do is probably not going to have as much scaffolding, all right, because we don't want to waste too much time doing it, but obviously you want to get it right. So if you need to do all that, then do so. All right, let me just see what the next one is. All right, question B. This is my second attempt at this question because I made one error at the start, and I'll explain what I did, although you would never see it. Usually I don't edit videos, but it was right at the very beginning, and when I went to check my graph, I was like, what have I done? And then I realized the mistake was at the very beginning, so that's very frustrating. So here's question B again, although you don't know it's again because I deleted that video. Amplitude is 2, period is 2 pi on n, so n being this number out the front of the bracket, which is 2. And so your period is pi. We've had a horizontal translation, pi on 6, so we've gone to the right, to the left, pi on 6, and we've gone up 1. Now, remember in the previous video with our scales for our x-axis, we did have a pi on 12. In this one, it's also easier to do pi on 12 because of this shift of pi on 6. So we're going to go as far as 12 pi on 12. I probably should go a little bit further because, yeah. And then we're going to do a shift of 2 pi on 12. So just changing it so we've got the same denominator. All right, I'm going to just do this one using dots. Okay, so we don't have to sketch the graphs. If you want to, you can go and join the dots. All right, so first of all, because we've got this reflection, I'm just going to do that separately. So before we do any of the translations, and you probably don't need, you can probably just do it when you draw it at the end. But I'm going to do the reflection first because we haven't done too many with reflections. And then I'm going to do the translations. All right, so putting in our scale. So same as before, going up by 3. So there's your pi on 4. No, not pi on 4, pi on 2, pi on 4, and 3 pi on 4, and then in the other direction, same but negative. Now remember, we need to be able to interpret these with a denominator of 12. So I'm putting them in their simplest form now. The previous videos and the previous graph, we didn't simplify it, but we're going to simplify it here, and they should be negative. Silly me. All right, and then your x-axis, so we've got an amplitude of 2, so I'm just going to do from -2 to 2, but you should know that we're going to be eventually shifting up 1 anyway, so I'm going to put everything else on as well. All right, so in orange, I'm going to draw the dots for -2 sine 2x. So we haven't done that translation yet, so it's a sine graph, still starts at 0, but this time, because it's been a reflection, instead of going up, we're going down. So at pi on 4, we're going to be at -2, then up at pi on 2, then up at 3 pi on 4, and then down at pi. Now, this is where I made the mistake. So you can see at the very beginning, I started at -2, and it took me ages to figure out how I made that mistake, because I got to the very end, drew my graph, was pretty confident in it, and then sketched it on Desmos, and I was just like, what? Where did I go wrong? All right, so that's just our dots. All right, you can join those dots to make your sine curve if you want to, but you know, you don't necessarily have to. I'm just going to go one further down there, all right, because we're shifting our graph over, so we always have to end up with a dot over that side anyway. All right, so let's do our translations. So you can do these. So we're just going to do dots again. You can do both translations in one go, but I'm just going to do them separately. So I'm going to do the vertical translation and then the horizontal translation. So our vertical translation, we've gone up 1. So I'm going to do that in green. So I'm just going to go move that orange dot up 1. And this is good with mapping as well, if you wanted to know how a point has changed. And you'll see that our range now, because our shift has gone up 1, our range is now from -1 to 3. So our minimum value is -1 and our maximum value is 3. All right, and then we've got let's do it in blue. We've got our horizontal shift. So our horizontal shift is moved across pi on 6, which is 2 pi on 12. So every green dot is just going across 2. All right, so you can just work your way across. Now there's a lot of dots. This is why if you're using just grey lead pencil, grey lead is such a dot. It's in the wrong, oh, that dot's in the wrong spot. Yep, that was the only one in the wrong spot. Sorry, didn't count. Can't count to 2. There we go. So we're just moving 2 across. I was moving 3 across. You can do crosses or whatever, all right, to distinguish between them. All right, I'm just going to double check that I've only gone across 2 for all of them, because when I draw my dots, when I draw my curve, things should be symmetrical. All right, so there's a lot of dots there. Using different colors helps me see which ones to join. So obviously the blue. Now we're going to be crossing the x-axis just like we did in the previous one, and the y-axis. We should be putting those axes intercepts in, but because we haven't done solving equations yet, we're just going to leave it for now by just sketching it. But after we're done solving equations, we'll revisit sketching and just go through how to get the endpoints. So we'll have to do the endpoints too. All right, so just joining the dots. So don't worry where it crosses your x-axis. We're just going to join the dots of the blue. This is very wonky. I'm doing it one move. There we go. All right, so there's your sine graph. You can then just rub out your other dots. All right, so see how, just using your dots is fine, but if you wanted to sketch the other curves, you can. All right, so there's your sine graph. Why does that look so long? I feel like that's a bit long. Okay, so there's your endpoint there and your endpoint down here. So I do need to get rid of, not the whole graph. Let's change the eraser. Let's just do a point eraser. All right, we need to get rid of that part too, and just this part here. All right, so just make sure you do stop and start at the right endpoints. Okay, so I'm just going to double check that on Desmos before we move on to the next one. And here it is on Desmos. Just make sure it is the right one. No, whoops, haven't got my translation in yet. I got rid of it when I was exploring what my problem was. Pi on 6 plus 1. There we go. So you can kind of see it's the same, which is good, which is what we want. All right, let's move on. Okay, just a slight glitch. All right, let's move on to the third one. So let's try to do this one a little bit faster just so we can quickly end this video. Oops, so this is question C, y equals, and I've written these on. I'm sitting in Miss O'Leary's office and I've just written them on one of her pads of paper, and she's going to look at it and be like, what is that? She'll probably know it's me because I'm always hanging out in her office. Plus pi on 3. Oh, not pi on 3, root 3. Okay, let's go through the important things. So your amplitude is 2. Your period is 2 pi on n, which is, again, pi. We've gone to the left, pi on 4, and we've gone up root 3. Don't worry about this root 3. You just treat it like an integer. Okay, so we're going to do the dots again. All right, so let's get our scale correct. So we're only going across pi on 4, so we don't really need to use pi on 12 as our scale, okay? Because if I just group these, and it doesn't matter that I'm even going up by 4, 1, 2, 3, 4, I'm just spacing it out really. All right, so if we've got pi there, pi on 2, pi on 4, 3 pi on 4, my scale is already pi on 4, so I don't need to change the scale here. If you like to, you can always just use pi on 12. Up to you, what works for you. Usually you'd be, given a scale. So, because we don't want you on an exam to spend so much time doing something like this, because it can be quite time consuming. Oh, what are you? Don't know why that's flashing down there. Okay, we've gone up pi on 3, so our amplitude is 2, so it usually goes from -2 on 2. So I say pi on 3 again, root 3. Now root 3 is somewhere between square root of 1 and, square root of 1 and the square root of 4, so our two perfect squares. So it's going to be 1 point something. If you want to get the exact value, it's going to be closer to 2 than what it is 1. So because I'm running out of room here, I'm just going to put it up here. So that's going to be 2 plus root 3, and this is going to be -2 minus root 3. All right, so we'll just leave it for that. Oh, no. Why am I putting that there? I need to put it up here, don't I? Where would we be? We'd be up here. So that's -2 plus root 3. It's probably not the nicest thing to write here as an exact value, but I will do that. So -2 plus root 3 is here. All right, so if we check the decimal answers, just so we're on the right track, because I probably shouldn't leave it like that. There we go, 3.7, and then -2. Oops. I'll just do root 3 minus 2. Root 3 minus 2. All right, so we're kind of roughly in the right spot. Okay, so maybe that one can go up a little bit more. Doesn't really matter. Although I didn't shift it up too high, did I? All right, so like we did, not the previous one, but the previous one, we just did a dotted line. So remember that's our minimum. And there's our maximum. Oops. You should be using a ruler. Me, not so much. Okay, and then our halfway point. So we've gone up root 3. So our halfway point is going to be, what was that, 1 point? So we're going to be up here. Square root of 3. It's roughly there. Okay, so and you can see it's halfway between those, your maximum and your minimum anyway. Gosh, that's very wonky, isn't it? Okay, so normal sine graph. No, this is a cos graph. Normal cos graph starts at your maximum, so up here, then goes down, and then hits the minimum, then back up, and then hits your maximum. All right, other direction, so middle line. Make sure you go all the way to the minimum, not onto your x-axis. See how I'm going just below? All right, and then up again. All right, and I should really have put this other point in. So 1, 2, 3, 4. There it is. Okay, so there's your cos graph. So you can kind of, if you want to, draw your dotted lines, but I'm just going to do the dots. Okay, then so we've done the horizontal shift. Okay, so let's just now do we've just done the vertical shift. Now let's do the horizontal shift. So we've got to go across pi on 4. So pi on 4 is basically we're shifting it across 4 parts. So this point here is 1, 2, 3, 4. So you'll notice that it's now directly below that point. Okay, and this point 1, 2, 3, 4 is above that. All right, so let's just move them. Think of them as just shifting them across. It's probably easier than saying that it's moved directly above, but the thing is, because it's pi on 4, that's why it's directly above them. All right, so then, all right, we don't need to do that next one. All right, so it's there, across. 4, this one's moved across 4, and this one's moved across 4. Alright, and then this one's here, and then this one is here. Alright, so we just want to do the green dots, and this is our final graph. So we've done everything. There it is. Wonky wonky. Alright, so it's easy to see your endpoints here because you've shifted across by pi on 4. And pi on 4, because you split pi into 4. That's why it's this endpoint here. So you can write that endpoint if you like, which is negative pi root 3. And this one here is pi root 3. As for the x-intercepts, we'll do them another time. All right, I might, just before I end this video, check it out. If there's any mistakes, I'll come back and fix. Otherwise, ciao!